Generation of refrigerants? ESCO Institute can help you learn the information you need with the low GWP A2L refrigerant safety course. Did you know newer refrigerants are less harmful to the environment? Did you know there are new standards for the transportation of low GWP refrigerants? Did you know most A2L equipment will require refrigerant detection systems, and you will be required to use no spark, no arc tools and equipment? Get the facts! These are just some of the things you need to know to work on new equipment. Take the online course to learn more. The ESCO Institute Low GWP A2L Refrigerant Safety course is interactive and engaging and will prepare you for the Low GWP A2L Refrigerant Safety Certification exam. You will find the Low GWP A2L Refrigerant Safety course on the HVACR Learning Network, the industry's leading source of online and digital content. Visit hvacr.elearn.network today.
Well, hello, HVACR world. We're so grateful to be hanging out with you once again. We're spending some time diving deeper into A2L equipment. Remember, I keep talking about we're going to have a mobile studio here very soon, like hopefully picking the thing up next week. We'll still have all the equipment installed, and we'll have a variety of things to get ready for that. But we're going to be spending a lot of time helping you understand the installation when it comes to working with A2L systems. So we're going to dive a little deeper today with the refrigeration side of things. I know we spent a lot of time talking about the A2L transition in residential and light commercial equipment, and we've spent a little bit of time brushing on what the refrigeration industry is doing, but now we're going to spend some time actually looking at an installation. We're going to get a better grip of what it is, especially from the technical side. So today we're spending some time with Chris Austin, field support engineer with heatcraft. How are you doing, my friend?
I'm doing great. Thanks for having me, Clifton.
And you're joining us from California. I'm just outside of Indianapolis. Let us know in the chat, everyone, where you're joining from. We'd love to know, the vastness of our community. We tend to have an international, presence every week. We have a lot of people from around the world looking at what we're doing here in the United States as kind of a leader for this whole HFC phase down and transition. And so when we start talking about this transition, Chris, Heatcraft has really taken a very, very cool approach to this. Because when we look at it from the service side, maybe we're going to be just replacing an evaporator. And maybe we've got an existing HFC A1 classified system that we may not be ready to completely retrofit. Or maybe we are ready to retrofit and we need to see what those solutions are. And there's a lot more solutions in the refrigeration than there is in the residential sector. Katie, thanks for joining us. Paul, great to have you here from South Jersey. Osvaldo down in Belize. Glad that you're hanging out with us, Osvaldo. I know this is a lot of great stuff, and hopefully we're filling the brain with information. David Harrell, great to have you here, sir. So let's kind of talk about the transition in the commercial refrigeration, because you've spent most of your time as a technician in the field. It's where I spent most of my career, was in refrigeration. And so you're doing the technical support. You're also doing the site work. Just came back from one in
Phoenix, Arizona. Well, Glendale, Arizona, excuse me.
There you go. And so I know you've been doing a lot out there. Oh, yeah, very cool. Glad to have you here, Kevin. Ecuador in the house. Absolutely. And if you have any questions, especially, Kevin in Ecuador and Osvaldo in Belize, if you have any questions or comments, especially about the refrigerant transition, if you're seeing it there, let us know, because this is all very exciting for us. I would call us refrigeration nerds. I'm going to speak for myself. I don't know about you, Chris.
Yeah. I grew up in this industry, and unfortunately, I talk shop more than I talk anything else. So definitely a refrigeration nerd.
All right, so let's talk about the technology. We're going to have a variety of things to share with our audience today. I've actually got a Heatcraft leak detection system with the mitigation control. We've got our isolation valve, check valve. So we have a variety of things we're going to be able to do some hands-on with. We're going to go through some presentation. And then we're also going to have a lot of site photos from a conversion. that has recently happened, and a bunch of information on that, and the information for the case study for it as well, and a downloadable link. When we get to the downloadable link, I'll make sure to throw that into the show notes so you have access to it. And there's a QR for that too. Matter of fact, I think that's in the presentation. Yeah, absolutely. All right, so Chris, let's kind of talk about this, right? So from the technician perspective, we're really going to show you what you're going to encounter when you're out in the field. This particular one, super common installation. So tell me a little bit of the background about this before we dive into like some of the photos and such.
Yeah, so this was an existing walk-in freezer in Glendale, Arizona. Some would say hell on earth on that week. It was about 115 degrees the week that we did this change out. So we gave it, the absolute worst that you could throw at something, or within reason, the absolute worst. This was an existing bone system. Had some issues. I'm not familiar with the issues that it was experiencing. I know it was about 20 years old, so could have just been tired.
Life.
But at any rate, the contractor came to us and said that he had the and we had been in talks with one of our suppliers that we wanted to do this case study. So this was the perfect opportunity to prove that our dual refrigerant class would be viable in this situation. We just and our dual refrigerant class is essentially A2L ready, but it can be used with A1s also. So as you were stating, if you're got an old system that maybe they don't want to change out the evaporator just yet, or vice versa, and they still want to use your R404 or your 448A or whatever gas that it may have been using before, this will allow you to still use that old gas, but in the future you will not have to change this evaporator or the condenser at that time. It is rated for both, and it will just require the installation of our RDS kit to make it UL compliant for A2Ls.
Yeah, very cool. Yeah, Emmanuel, thank you for joining us over at Gustav Larson in Colorado. And Osvaldo, we're going to spend some time diving deeper into that. We're actually working on an A3 curriculum to start getting the industry prepared for more of the smaller capacity A3 refrigeration systems like your R600A and the R290. So a lot to go about that. And yeah, Kevin, that's one that we haven't gotten into yet, but we will, especially with the amount of CO2 that's coming to the industry. We'll dive into some cascade systems sometime in the future. Yeah, Leanne also joined us from Colorado. You had quite a bit of presence in Colorado this time. Glad to have you all. Yeah, and it's really cool when we think about that transition, because if we're not transitioning from an A1 refrigerant over to an A2L yet, you're going to at some time in the future, right? This whole HFC phase down, we're talking, should be 85% reduction by January of 2036. So, a little over a decade. And we're already seeing places like New York that is struggling to get 404 for freezers, right? There's state regulations that are doing their own thing. So
well, yes, and that is heatcraft. We're ready regardless of what the states decide. There has been much chatter regarding federal versus state. That was another goal of heatcraft. Our equipment can be used if you don't want to use an A2L and it's not mandated where you are. You can still use it with A1s, but it will be you can get it A2L ready. So if those regulations come down at some point, you're already prepared. You don't have to go back to your client and tell them, oh, you want to upgrade? You're going to need a new coil and a new condensing unit. And you avoid that awkward conversation, especially, I was a contractor for many years.
Right.
I don't like having that awkward conversation with my customer of, well, I sold you this 5 years ago. It's obsolete now. You're going to have to replace your entire system.
Yep, absolutely. So what we're going to be showing you today is a really cool solution. And so this one was installed at the Glendale Elementary in Glendale, Arizona.
Yes, this was at an elementary school. Perfect test for this equipment. As you can see in the pictures there, this is a outdoor walk-in. 3 of the four walls face the southward facing sun.
Ooh,
So they,
poor thing.
yeah, and the condensing unit sits up on top. It looks like it's shaded, but it was hot up there. I will vouch for the contractors and myself that were there. When we were up there charging and wiring, it was plenty warm. It made me appreciate that I'm not in the field every day anymore.
Yeah, no kidding.
Um,
Yes, South
so
side on the southern part of the United States, that thing's getting sunlight from daylight to dark.
yeah, it was definitely warm. They got, by the time I had gotten there, they had removed the old system. We were in the process of hanging. They were in the process of hanging the new evaporator coil, and
Right.
it was already in the 90s, and that was at 7:45 in the morning.
My
So,
goodness.
and keep in mind the freezer had been shut down at that point because it was not during the school season. So it
Right.
was just as warm in that walk-in freezer.
So we're taking out a two fan R448 system, and we're now going to be installing a 454A A2L. And it's really cool that you're using the 454A. So we've been discussing here recently the difference in refrigerants. We've went through a lot of refrigerant chemistry. In that 454A, because people go, wait a minute, is that close to 454B? Well, yeah. So we actually have 454A, B, and C, all with different proportions of R32 and R1234YF. And the 454A is turning out to be a really good solution in these low temp applications. So,
Yeah, and again, this is my first experience with an actual real world case study.
yeah.
And just to elaborate on what was done here, we took the old system out, and the three fan coil that's superimposed behind me
Yeah.
is the coil that we put in there in Glendale. That is from the job site.
Okay.
So we did put that three fan Intelligen coil in, and our goal here was to not only show that the A2L worked, we wanted to get a real world comparison versus our 448. So we installed this on July 1st, and we charged this with 448 and programmed it with 448 in the Intelligent
Oh,
controller. So
okay.
we and watched this cool down. Again, this was a hot box startup. The box was 95 degrees when we fired it off. So we had high suction, everything that could possibly be against you to start: high ambient temperature, high box temperature. And, other than, needing to throttle down our suction valve a little bit at startup just to keep the compressor amps down because it
Right.
was so hot in the
Yes,
box.
it's a load. Yeah.
Yeah, it was under such load. We cooled this box down within a couple of hours, and it was hot. This fan coil may seem a little overkill for the size of box, but again, this was sized for real world application here in Arizona that in the summertime is going to be exposed to tremendous heat load. So it is what we would traditionally feel maybe oversized, but it is sized dead on for what they're experiencing here.
So that was
And so we got this installed. Um, I think we had it fired off by about 1 o'clock, and by 3 o'clock we were down below freezing. Obviously not to -10 yet,
right.
but well below freezing, and everything was functioning as we expected. So we left the job site that day, allowed Intelligen to do its thing, and our process here was we're going to come back in 1 week. At that time, we're going to download the USB log, another great feature of Intelligen. We
Okay.
can log all of everything that system has done for the last 60 days is logged and can be
Right.
downloaded to a USB log for troubleshooting or fine tuning. We downloaded that, and then the contractor proceeded to recover the charge, and we and then install the RDS kit, the liquid line solenoid isolation valve, and the check valve, all on this day, to show how long it would take in a real world scenario to do an A2L conversion.
True conversion.
A true conversion, yes. This
Yeah.
was not something that day one we put the RDS in and we put the solenoid in the check valve and just ran it on a different gas, came back a week later and switched gases and said, Okay, yeah, it worked. No, but this was a true real world scenario of what your average contractor would experience. You or myself out there, you know, got a 20-year-old coil that develops a leak, and maybe you just put a new coil in a year ago, and now the condenser has died and they have to go to A2Ls. Well, you already have an existing coil. Here's how we would do this.
Okay. All right. And so we're going to go through some of these steps and show, what that difference is between the A1 and the A2L. And I myself am an advocate for, even if we're doing an A1 installation with an A2L compatible piece of equipment, it's worth installing it because at the least we're adding some refrigerant leak detection to that system, right? It may
Mhm.
not be tuned as well as an A2L refrigerant is for detection, depending on the sensor that's used, but at least it's adding that additional security. And, we're also getting all the modern controls that goes along with that system.
Yes, absolutely.
All right. So so this is that case study. I think I'm going to go ahead and throw a link to this where did I put it? Oh, there it is. I had to change screens just for a minute because I had it in the notes of one of the other slides. So in the chat, I'm going to throw this link out for everyone. And this is to get you to this entire case study so that you can dive into this information on your own and get an idea of this entire project. So all right, so let's go over here real quick. Do we want to start with some of the photos of it, or we want to dive a little bit deeper into the case study?
You know what? If you want to show some photos and we can kind of tell them
Through.
what each one is representing, that would be fine by me.
Okay, we can always come back to this. Anybody has any questions here after a while? So, one of the first things that I noticed, looking at our unit is, no major differences. It looks like an evaporator coil,
Yeah.
right?
And for to the untrained eye, that's all it. That's the only. You're not. No, the untrained eye will not notice any differences.
Right.
There are subtle differences. Our connection points on the back of the coil are protected now. You're going to see a metal enclosure on those. That wasn't something that was required with A1s. A2Ls is there. The other thing that notably that I noticed stuck out like a sore thumb to me was now there is a grate across the back of the evaporator that protects the coil. Obviously, we as technicians probably know why that's there.
Right.
Somebody has gone in and seen ice on a coil. I've been called out on a weekend more than once for somebody that de-iced a coil with an ice pick, not knowing that there was a refrigeration coil behind there. Obviously, that grate is not going to 100% prevent that, but it is there as a warning, or hopefully somebody, and you can vaguely see it there in that picture.
See that.
But yes, that there is a guard on the back of these coils now. All A2L ready coils will have that. So there's subtle differences we're going to notice with A2Ls, other than the obvious that you can see on the coil behind me, a big sticker that says A2L. We can't make it much more plain and simple to people what's in the system. Now, hopefully your installer marks what A2L they put in it. That's a whole other thing, that people tend to forget to mark what refrigerant they put in, anymore. When there were only 3 refrigerants 30 years ago, it wasn't as critical, but it has definitely changed. And to the technicians out there, please mark what you put in your system. It would save us in tech support a lot of time figuring it out, and it's just good practice.
Absolutely, it is. Yeah, Scott, I'm glad that you're joining us. This is a resource designed for you, right? To make sure that you're getting all of the tools that you need to be successful in the classroom, as well as our contractors and technicians out in the field. I know, like myself, once we come out of the field and we start spending more time in the classroom, we really need to have this type of training where we're getting this, may not be hands on, but by golly, it's close enough. I can see what's changing in the industry so that I can prepare our students and prepare our technicians for what they're going to see. And yeah, Josh, you're right. Here in Indianapolis, Most of my distributors, at least on the residential light commercial HVAC side, they don't have any A1 systems left. Everything that they are pushing out the doors right now is an A2L, but we still have access to A1 refrigerants in many areas. And that's a reason we want to show that you can do both depending on what existing system you have. Because what if you, like I said, what if you lose an evaporator, but you still have a relatively new condensing unit that is designed for an A1? Well, you're going to be putting an A1 refrigerant of some type back in that. And, at least we're being prepared for that next step. Ooh, yeah, Kevin, I can't wait to talk about this a little bit later, because we're going to be seeing more of that here in the U.S. Yeah, and Chris, that case study, yeah, it'll really help see what we're diving into. This as being an excellent resource.
I see a couple of my teammates on here. Hey, Josh. Hey, Chris. Good to see you guys. Thanks for joining.
Yeah, glad to have you here, and I'm sure we'll get both of them sometime down the road to join us. Now that we can show you that we do have a lot of fun here, right? We spend time talking about this transition, bringing real life scenarios into into this environment, just to be able to show everyone that it's really not as difficult as sometimes gets portrayed as being.
One thing I do want to point out here, Clifton, as we go through this is something that when I arrived on site that I noted and that is often overlooked with evaporator coil spacing.
Yeah.
Heatcraft does have recommendations for that. Our recommendation, as long as I can remember, for these low profile style coils has been 1 1/3 times the height, which is 18 inches away from the wall.
Okay.
Now, when I arrived on this site, this coil was not mounted that far out. To no fault of the installers, they put the new coil exactly where the new coil or the old coil was.
Right.
Well, one thing we have to keep in mind is now that we've transitioned to ECM motors, they do have internal sensors and work slightly differently than our old PSC and Cannonball motors.
They don't like static pressure.
They do not. And we have seen time and again, this is from my experience as a technical support agent on the phones, coils that don't get put in as we recommend, a lot of times see what people interpret as a bad fan motor, where an ECM motor will cut out. Yep. And especially on a 2-fan coil, you will have your right fan run, and then your left fan mysteriously comes on and the right fan goes off at the same time. And I've taken multiple calls where someone has thought maybe they have a control issue in Intelligen or that, not realizing that the motors are wired in parallel. They run at the same time when they have power. Internally, they're being controlled. Right. Well, the more calls I took and the more people told me, hey, we keep replacing these same motors, we started asking more questions.
Right.
It can't just be, everybody has had a bad motor some point in their career, but this seems too common. So what we found was, and through investigation, is a lot of the times, or most of the time that we were having these issues, the coil spacing was incorrect behind, maybe 12 inches. And, unfortunately, at that time, the coil's already been mounted. It may be a year after it was installed. You can't really tell that, your contractor, you need to move that coil. So as a solution, we might have them put a PSC motor in and let them know, well, this does void a DOE or AWEF rating, right, but it'll get you going. Well, with A2Ls, we can't do that.
Right.
An ECM motor is going to be required with an A2L because it's spark proof.
Right.
So, just to the people out there that are moving forward, we don't as manufacturers just put out these guidelines arbitrarily. There are some important reasons for it. And just because we might have gotten away with doing things different in the past, the tighter things get and the more, and I don't want to use the word dangerous because I don't feel A2Ls are dangerous, but there are precautions that need to be taken that didn't exist 30 years ago. And we do need to be, very conscious of those and, avoid putting ourselves in situations that, could be dangerous or, we are dealing with a flammable gas, partially flammable. It's still, we need to have a healthy respect for it.
Absolutely. Well, let's talk about, what we're going to see since it is a different refrigerant. It does have that mild flammability to it, although it's a little disappointing, the flammability, but it is mildly flammable. So we're going to see some differences, right? But when we start looking at operating pressures, we may have, metering device changes, but when we start looking at the capacity of the system, we can comfortably use A1s and A2Ls in the same component. We just make sure that we have the correct safeties on it. So this particular one, on the, facing the coil on the right hand side, once we remove the cover, we're going to see some things that may be a little different than what we've encountered in the past, right? You're going to notice immediately on this one,
You
I'm
you
already
can you can see your refrigeration detector sitting down there on the bottom right.
exactly. And, to be able to get access to that, once we remove that right panel, right, there's that A2L. So if it was an A1 system, we wouldn't need the A2L sticker, but with an A2L application, we can put the A2L sticker on it. And then we're going to be able to gain access to that electrical control. And I love this swing out control that you've put on. I've seen them on a variety of different coils, but now with that A2L, that gives us the ability of having the A2L control very accessible from the side by swinging out the control and
Yes. And engineering listened, guys, technicians in the field, engineering listened. This can be swung away and accessed even when the product is in the box. You can swing that and see it from the front. You're not over there with your neck, in this position, trying to get in there to see a blinking light or anything like that. This will fully swing away. One thing I will note to you, the installers and people that would put these RDSs in, when you're routing your wires and converting, route your wires through the hinge side, so that as you open it, your wires don't get disconnected. It's, one of those minor things that would drive you nuts after you're done wiring it and you go to move it out of the way and go, oh
Wait.
man, my wires are too short, or oh, now I can't open this thing up to get to my other transformer for Intelligen that's underneath here.
Exactly. See if I can zoom in a little bit better on that. Okay. So Heatcraft has been so gracious enough to actually send me one of our A2L controls. Sent the shutoff valve, the check valve. So I went ahead and fired this thing up so we can see what's actually different about the A2L version versus the A1. So this coil is going to come with all of these controls, or is this a separate component for this coil?
Our A2L ready coils will come with this. Our RDS conversion kit, you will purchase these components as needed. Again, the RDS kit, your solenoid, you would purchase based off the voltage that's required.
Right.
Your check valve would be sized to your suction line. So again, one size does never fit all in refrigeration.
Exactly.
With your salesperson or your local wholesaler, you would need to provide them that information, and we'll make sure that we get you matched up with the right stuff, to make sure that your solenoid is, one, large enough, and two, your check valve is not too small, so you're causing a restriction in your suction line. Those things do matter.
Yeah, absolutely. I did notice on this particular one, it actually is a dual voltage solenoid. So this can be 120 or 240, just based on how you make the connections for it. This is on a 3/8 line. So
And I do like that feature. Again, as a technician that traveled and worked out of a truck, if I can stock one mitigation solenoid that will cover two applications, that enables me to have room on my van for another part I may need. All of that starts to figure into cost, and not only that, simplicity for us in the field.
Absolutely. So when we look at A2L control and mitigation versus the A1, this is really all we're looking at, right? If we were talking about a residential, light commercial, HVAC system, we were talking about a refrigerant leak detection sensor that's connected to a mitigation control board. And if there was a leak event, it's just going to shut off the ignition sources, shut off the outdoor unit, turn on the fans. Well, if we think about this scenario, say we've got our walk-in freezer, the fans are running most of the time, except for in defrost. What is going to be our sequence of operation if we were to have a leak on an A2L refrigeration system from Heatcraft?
Well, one important thing to note on our RDS kit is it also offers a warning before we will flash. And forgive me, I cannot remember what color it is. I'm just looking in our literature here. I believe it's going to be a yellow light will flash and let us know that there is presence of refrigerant, but it hasn't reached the threshold yet to require mitigation. Let me take a look in my
All right. And we'll start
literature here.
experimenting. Those that have been on the show before, what understand that, there's a lot of industries that use chemicals that we classify as refrigerants. So one of them, is the dusters. So the Dust Off
Mhm.
brand has actually went through 3 different refrigerants. They went through an A1, an A2, and now they're into generation A2L. So for test purposes, we're able to use this A2L refrigerant to be able to just get an idea of sequence of operation on our controls. So we can actually do a test function of that. So we'll experiment. It's going to be, I don't have a good way of measuring my parts per million to be able to get down into that lower flammability level. So we'll do a small one and see if we get any detection off from it. I'll be very gentle with it and see, because it's going to be sampling. Most of them sample every 5 seconds or so, and they're going to be looking for amounts of refrigerant.
Now,
And
I will say you're blinking red right now. This is still initializing.
okay.
So there is a 5-minute initialization from power up that where this controller goes through a self diagnostic, and basically I don't know if it calibrates itself. Again, I'm not a control specialist. But it is calibrating and initializing. So when that's final, you will see a green light. And that normally takes about 5 minutes.
Okay, excellent. All right, and so connection-wise, we simply have our incoming high voltage is going to supply power to our transformer, to our board, to our relay. And we're going to have our high voltage connections for our solenoid. Now, tell me about this solenoid. Is this a standard, like a pump down solenoid?
No, this is specific for A2L mitigation. There are differences, mainly being this is non-rebuildable.
Okay.
It is sealed. So, my theory on that, and you may correct me if I'm wrong, is by making it non-rebuildable, we eliminate the possibility of it leaking or being reassembled improperly. This is a safety device. We want to make sure it's as safe as possible.
Yep, absolutely.
So no, this is not now. And I have recently heard originally we were told that it could not be used as a temperature control solenoid.
Mm-hmm.
I have been told that it actually can be used as that, and a thermostat. Say you were using this on a regular mechanical system, you could wire your mechanical thermostat in series with that and have it and use this as your pump down solenoid.
Aha.
I don't know that I would do that, just because I don't know if I would want to be using my mitigation solenoid on a day-to-day basis, opening and closing.
Right.
But again, it has been said that it can be. Sporlan has told us that it can be used for that. So, that is something that, down the line, simplicity's sake, say you do just want to use one solenoid, you could.
Okay. And so that is going to be able to isolate our liquid supply. What about the suction side? Let's talk about the requirements on the suction side of our system.
So we are required to put a check valve in the suction side, and ordinarily I would say our compressor is going to prevent any kind of bleed back. But let's say we have a very long suction line, something of that nature, or we have maybe the compressor's getting tired and it bleeds back through a little bit. It happens.
Absolutely.
This check valve will prevent any partially flammable A2L gas from making its way back into that evaporator, into the walk-in box. So both of those are UL mandated for A2L refrigerants. You can't do one or the other. Both are required.
And you've done a really good job with this check valve. I mean, it's really not significantly different than the line itself. Some of our previous generations of check valves were kind of monstrosities. And
Yeah, no, these are nice and tight. You're not going to stick out like an eyesore, or be something that requires you to repipe your suction line for by much to put it in there on an existing install.
yeah, and I noticed a very minimal amount of pressure to actually activate. I don't know if we can see it, to be able to activate the check valve. So, I mean,
Yeah, and these check valves are not just a generic check valve either. These are A2L specific. They have been spec'd for that. UL recognizes them for that. So it is important for us to stress that this isn't just any old check valve and any old solenoid.
sure.
We still do need to use the correct parts for this. I mean, we are talking about a safety device here. So it is critical to stress that, yeah, you might carry a Sporlan solenoid on your truck with an MKC1 coil, but it shouldn't be used. You need to use the proper equipment in this case. UL mandates it. It's the only way that we can guarantee that your system, if it develops a leak, will be safe.
Gotcha. I'd actually had been testing this before the show, and I actually set it off quite a few times. So it actually may be.
Oh, you know what? I'm sorry, if you did set it off, another important safety note to note on our RDS kit. It will not reset itself. It doesn't matter how many times you shut the power off, how many times you tap the sensor or hit it with a wrench or whatever, we as techs have done in the past. The only way to reset it is to press the micro switch on it and reset it. That is another safety that we've built into that to prevent the client from going in and just turning the breaker off and on, and lo and behold, they're back up and running.
All right. Very good. So let's talk about the location of that, and I'll see if I can't clean that up just a little bit more. I love this manual camera, but the depth of it is not always the best. All right. So I'm going to need to actually do a reset on this control board. Oh, and I would imagine it's probably.
Your micro switch is going to be hidden by that white tab.
Yeah. So right there by my LED. So I will hold in that micro switch.
Yep. Press and hold that. There you go.
Look at that. Okay. Very, very good thing to point out. So we are back in operation. So we're in standard operating mode. And so let's go back and try that again. We're going to see if we have a very small refrigerant leak in the space. Not enough to hit the lower flammability limit, but enough to introduce a cautionary action.
And I believe, and Don Fort covered this with you when he was on here, and I watched it, and I forgot to write down the thresholds because Don knows his stuff like the back of his hand. If anybody's ever seen Don on here,
Yeah.
there
we go.
Okay, there we are. So that is, as you can see, you've got a yellow and a red flash.
Okay. So if we wanted, we could actually use auxiliary contacts to be able to set up an alarm or notification for this in the event you are in that.
That's correct. Up there on the top, we do have, and those are dry contacts. So they are not being powered through the control board. These would send out an external signal or basically we're just closing a switch there, or your external alarm that would let you know, hey, the lower, or we have something here. There's something that needs to be noticed here.
Exactly.
We're not going to shut your system down yet, but there is something that needs your attention.
And I did notice we actually have additional plugs for refrigerant detection sensors on this board.
Yes, so we can use up to 3 detectors on here. And again, our detector on these is going to be located near the bottom of near the drain pan.
Okay.
Which, because A2Ls are heavier than air.
Sure.
If you have a leak in your coil, your A2L is going to generally migrate downward, and that sensor is going to pick it up there. We didn't put it at the top of the coil because your A2Ls aren't going to be there. They're going to, just like with propane or any other flammable gas, they're heavier than air. you generally are going to find them near the floor or near the bottom of the pan. But this does allow us to mount additional sensors. Say, you want to put one down near the floor.
Right.
You could plug one in and put it down near the floor, and there are dip switches on that RDS that you can enable in order to use another sensor. So, again, this is a nice feature for, I can see there's going to be some fears regarding A2Ls. Maybe you're going to have a reluctant customer that is a little scared about having flammable gas in their walk-in.
Exactly.
Maybe an extra sensor will ease their mind. I think that we're going to find with A2Ls, the fear is going to be unfounded, just the same as when we went from R22 to R410A. Everyone was terrified about, we're going to be running these 600-pound pressures. Things are going to blow apart. It was highly unfounded. There were some isolated incidents, but it wasn't something that we saw happen, consistently or even to the amount to create fear. I think we're going to see that with A2Ls. But again, that's a great feature that allows us to maybe ease the mind of somebody who's not quite maybe doesn't quite want to go to A2Ls yet. That's a great way that we can ease their mind and let them know, hey, you're protected.
And we can add more if you want.
Yes, we can put up to 3 on here, wherever you would feel that you want them. And again, you can add an external alarm on here. And if this is plugged into Intelligen, Intelligen gets a signal from this controller, and when we reach the lower limit, or I'm sorry, where we detect it, but it's not enough that we need to shut the system off, a cautionary level, Intelligen's going to flash a yellow light for you and give you an error code. Tell you that, hey, there's an A2L. The RDS sensor is telling us that there's something here. It's not enough to shut down yet, but it might be time to call your technician and get out here and see if we've got a leak. I don't anticipate that being a problem in the short term, as everything's going to be brand new. But 5-10 years down the road, as maybe somebody's, kept onions in the box, or, and, acids have begun to eat through the coil or whatever it may be. That's a nice feature that, protects the client, and it may actually, prevent food loss in some way. Hey, we've got a leak. Your technician comes out, maybe repairs a leak before the box ever gets warm.
Exactly. Yeah, I love that. Now I'm seeing exactly what you meant by with the wiring, because remember, this is going to be a hinged door, right? So
Yes.
I've disconnected power to my unit. I'm going to move the wiring over where it should have been installed. And I have my short wiring here. And so I want to show you where this refrigerant detection sensor is. So if we opened up the inside, we're actually going to see the refrigerant detection sensor here, located on the back of our electrical panel. And I'm going to see how well I can zoom into this for everyone. Yeah, that's not too awful bad, I guess. We're looking at some different cameras for the portable studio, and I think I'm going to go with some auto zooming and variety of different cameras just so we can show these a little bit better. But if we go back to that one picture, we can actually see the sensor from the front of the unit. So there's that door, there's our transformer, there's our control board. And so when that side cover is taken off, you can see that this primary refrigerant detection sensor is sitting over here in a shielded area. Because I've had that question before. Well, what happens when we start building up ice on the return bins? Well, we have a cover.
You're quite a ways from, and again, this is on the electrical side of the unit. Your distribution tubes and that are on the other side. So, not to say it could never happen, but
Right.
The likelihood, chances are that long before the ice got to that sensor, the box would already be warm, or somebody would notice and hopefully call their technician and say, hey, I got 3 inches of ice on this coil, and my walk-in's 50 degrees.
Yeah.
Hopefully your client or your end user notices the temperature is warm long before ice builds to that sensor. But that sensor is replaceable. I believe they're giving it a 15-year lifespan.
Keep hearing that.
Yeah, under normal conditions. Now, one great thing to note about the RDS is it does have a self-diagnostic that, when you can press the button and it does test the sensor to see that it's good. If it's not, it won't allow the system to go into operation.
I see.
So, again, that's another safeguard. And one great thing I do see about our RDS kit is it's using components that we're already all used to. It's check valves, solenoids, relays. It's very simplistic. It doesn't require interface. In fact, it can't have interface with an outside control other than to send signal out. UL requires that a refrigerant detection system cannot, if it's being acted upon by another component, that other component has to meet A2L regulation also.
True. Absolutely.
So that one great thing about this is it's simple. It acts on its own. A technician never has to guess, oh, is it my RDS kit or is it my Intelligen board that's causing this? No, your Intelligen doesn't have any control over your RDS kit. Other than it getting a signal from RDS, it doesn't control it.
Excellent. So you mentioned that. So when we look at the outdoor unit, I mean, we're really looking at just a traditional looking outdoor unit. We don't have additional refrigerant detection sensors. We don't have additional controls added to it.
The main thing that was different there, again, and that was more clear, if you go back to the last picture, see the grate in front?
Oh, sure.
That would not be on your traditional A1 condensing unit.
Okay.
So that is something that's included with A2L A2L condensing units.
Yeah.
And the main difference you're going to see is on our receiver tank. And Don Fort touched on this with you also, but we do have, a traditional fusible plug on the receiver tank. The difference on these is we have a threaded additional that will allow us to put a piece of copper or some sort of tubing off of it to route the partially flammable gas away if this was an indoor installation.
Yeah, which is very common. We see a lot of these, inside of, especially restaurants, it's indoors and it's just releasing its heat into the space. And so it gives the opportunity to plumb that outside.
Yeah.
Otherwise, it looks like a pretty common installation.
Yep. Now, one thing, that needs to be addressed with A2Ls, again, our solenoid and our check valve, you'll see where we place them. In this instance, on that picture that you see there, this is the initial installation before A2Ls.
Right.
Where we ended up putting the solenoid valve, because this was a short run, we ended up putting it just to the left of where the liquid line leaves the condensing unit there in that picture. So about where his clamp is holding the insulation back.
Yep.
That's where we put the liquid line solenoid in this case, because it was a short run. But the general consensus and the safest thing is for us to put that solenoid as close to the box as possible, but outside the box. Now, on a short run, it becomes less and less critical. But let's say we have a 150-foot line run. If we put that solenoid near the condenser, we now still have 100 feet of liquid line that potentially could have a partially flammable gas in it. So we want to have that solenoid as close to the walk-in as possible so that we trap the least amount of A2L within the area that we are trying to keep safe, which in this case would be inside the walk-in.
Okay, I don't, if there was a photo, I don't know that I grabbed that one. One of the things that I did want to brush on, you had mentioned the intelligent control. Oh, this one might actually have had it. No, I think that was the original installation. You'd mentioned on the intelligent control. Tell us a little bit about this control.
So Intelligen is our latest electronic control system. Very basics, in my opinion, system. I mean, we're using an electronic expansion valve. Its primary purpose, again, is for temperature control. Once we call for cooling, it is controlling superheat. It's monitoring our suction pressure and suction temperature and adjusting that EEV to maintain that 8 degrees of superheat that is our factory default. And that is adjustable from 4 to 20. So we do have a range there. Some applications require lower, some require higher. So that is there. Intelligen is very simple. We don't need, it does eliminate the need for a defrost timer, fan delays, liquid line solenoid, and it eliminates the necessity for a wiring between a condensing unit and your evaporator. This Intelligen evaporator can be powered off of its own power supply, and there is no communication necessary between the evaporator and the condenser unless you have an Intelligen condenser, which would require you to have low voltage wiring between them. You would run basically a traditional thermostat wire with a minimum of 2 wires, and our control circuitry is going to be powered by our Intelligen evaporator. We send a 24-volt voltage signal up to the condenser, which activates the controls. But very simple system. We've been using, electronic controls now since the late 90s. It was introduced with Beacon 1. Beacon 2, we saw vast improvement with. Now Intelligen, I sometimes call it Beacon 3.0. I hope that my engineers don't hate me for that, but it does function very similar to Beacon. We've just added a whole lot of other great things that it can do. One of them being, and Beacon 2 had this also, but refrigerant selectability. So in this instance, when we turned this for 448A at initial installation, we powered up our Intelligen controller. It comes up to basically a programming screen that tells us Intelligen Simplicity Refined. We put a PIN number in. We follow 14 steps to program that evaporator for its application, temperature, defrost type, and it does ask us if we have a CU wired, which is a wired condensing unit. Basically, that's asking us, do we have an Intelligen condensing unit matched with this, or do we have a standard pump down condensing unit like we've used for the last 100 years? So at this point, you would program this, initial programming. We programmed it for 448, set it for low temp electric defrost, set our temperature at -10. Once we click start system after doing those steps, that's all we had to do. It came on. We had a 4-minute time delay before it opened our expansion valve and went into our cooling cycle. At that point, no going back at the end of the day and setting a TXV superheat. Superheat's being controlled by the computer. And one great thing about EVs, we can maintain superheat across a much wider spectrum because they have much greater capacity. The 201 valve that we use in this particular coil would be good from maybe 3,000 BTUs all the way up to about 48,000.
Really?
So one valve covers a vast array of application. Again, as a technician, you mean I don't have to carry 27 expansion valves on my truck? It's a great feature. But for the A2L conversion, what's great about this is we didn't have to change the expansion valve. We didn't have to change a nozzle. All we had to do was, when we do go from an A1 to an A2L, one thing that we do have to do with Intelligen is we have to factory reset the control board. We can't just change to an A2L refrigerant.
Oh, I got you.
It does require a factory reset. Now, for a traditional A1 system, to go from 448 to 404 just requires turning the knob and selecting a different gas.
Okay.
To go to an A2L, we do have to factory reset. I haven't talked to the engineers to find out why that's required. I think because it has to look for the RDS kit at that point. I believe that's why the factory reset is required.
Makes sense.
But at that point, we factory reset, went through our initial 14 question programming. The only difference being now we had a 15th question. When we select an A2L refrigerant, the next question will be, is an RDS present?
Hmm.
If we select an A2L refrigerant and there's no RDS, it will not allow us to use the A2L refrigerant.
Okay.
So again, that's just another safety that we've built in to protect the end user and the contractor. Maybe you've got a contractor that's not savvy on regulations. Well, if he selects an A2L, if he doesn't say that yes, he's put an RDS in, he won't be able to use. He will not be able to finish programming.
Wow. Very cool. Good safeguard, right? 'Cause there's
Yeah,
a lot of technicians and contractors that aren't aware of the requirements for A2Ls, and it's at least makes them aware that, there is some differences here.
yeah.
Let's take a look at things. Let's actually read the manual for this thing now.
Nobody reads the manual. We throw that away and then we say this thing sucks or whatever we say because we didn't know how to use it.
Great. So those bad habits that we're trying to repair within our industry.
Yes.
Well, so much great information. We still have a lot of people hanging out with us. Anyone have any questions? Have anything that you would want to dive a little bit deeper? We've got the case study. Where can we learn more about Heatcraft and the solutions that Heatcraft has available for the industry?
Our website is heatcraftrpd.com, and RPD is Romeo Papa Delta. And we also have our Intelligen specific site, which is intelligen.heatcraftrpd.com.
Okay.
And again, that is specific to Intelligen firmware updates, things that just pertain to Intelligen. You will find at intelligen.heatcraftrpd.com. It is a great resource for technicians who may have a question specifically to Intelligen. There's links to all literature, firmware updates, and are available there. Instructions on how to update the firmware are all there. Details of our IFM kit, which allows you to use Intelligen but mount it 40 feet away from the evaporator. Another great feature that we've have introduced that has a lot of great applications.
Cool. Yeah, so much great stuff, Chris. I'm glad we had the chance to hang out. I'm thinking it might be worth doing an Intelligen training sometime and go through the different menu options and just kind of walk through what the different selections are. Sounds like we have a lot of really cool functions, and it'd be a good one to
And
talk.
Intelligen has so much function. In fact, I deal with it every day, and I'm sure that I don't know everything that it does, but it's a great control. I was one of the old school technicians that hated electronics, and in the last 4 years of working with it and getting to understand how it works, it's great. It's very simple. It's just we need to educate. People need to understand how it works. Once you understand how it works, it's very easy to diagnose why it's not working.
That's exactly right. And that's what we're here for. We're here to bring you firsthand education from the manufacturers. We don't want you learning through cousin Bob, who might have learned some of the right things from Uncle Joe.
Mhm.
We really want to make sure that you're spending time with the top educators and instructors from our industry, that you're getting connected with our equipment manufacturers and the training that they offer. Tell us a little bit about the training that Heatcraft offers to the industry, because there's a lot of educators I think would love to learn more about what resources there are for learning firsthand about the products, as well as contractors and technicians that would like to brush up their skills on
Yeah.
equipment.
So we do offer training in our Stone Mountain facility. And again, you can find that at our heatcraftrpd.com website. You can find that under training. We made it pretty simple. We do offer classes on everything from CO2 to Intelligen to even basic troubleshooting. Don Fort and Justin and Chris Thomas, my boss, and even some of our other FSEs and myself are going to be offering training to the public in order to better educate everybody on our stuff.
Love it.
Again, and special requests can be made if you have a large company or if you have a group that needs training. We have done that also, where we go out and we go to a supply house, or we go to the local, union hall, or even to, a contractor's office and teach them firsthand. I was at one of our walk-in manufacturers 2 weeks ago and offered direct Intelligen and RDS training there. So we do offer that. And again, that's all available on our website.
Awesome. Well, Chris, thank you. Oh, cool. Juan, thanks for joining us from Nicaragua. Glad to have you here. Yeah, and spread the word. We love having all of our international brothers and sisters joining to learn about HVAC and refrigeration, and because the entire world is going through new technologies, innovations, as well as refrigerant transitions, and it's important for us to all stay connected. And this is one big community, and we're here to support you in a positive and encouraging environment. And Chris, thank you so much for joining us, Heatcraft. We're grateful that you allowed Chris to spend some time with us diving into some of these innovations and refrigerant transitions. And yeah, anytime you want to join us again, love to spend some more time with you. This is a
I,
great
I
conversation.
would love to, Clifton. Just send me the invite if I'm available. You can. I'm more than happy to share what I do know and learn more from you guys.
Awesome. Well, anyone has any other requests for trainings from Heatcraft, let us know. My email is cbeck@escogroup.org. I would love to have a little bit of input from you. And Don, thanks for joining us. This is great stuff. We're so glad that we continue to grow week after week. And hopefully we'll have us a mobile studio here in a few weeks, and we'll really be out on the road doing some physical training and spending some time with our equipment manufacturers at their facilities. Cool. All right. Well, thank you so much for joining us, everyone. And we will see you all again next week on Did You Know? The